Okay, in this video, what we're going to do is we're going to come up with a particular formula that helps us find the sum of an infinite geometric series. So to begin with, I've got the sum of a geometric series formula put up here on the board. Now, when we did the previous example, we had a common ratio of 1/3. It was a fraction. And when I took that fraction that's less than 1 and I raised it to a really big power, as n approached infinity, meaning plug in a really big number for n, that part of my equation turned into 0. I'm going to say that that would be true for any particular geometric series if the absolute value of r is less than 1. Okay? If my common ratio, what I'm multiplying by, has an absolute value that's less than 1. Absolute value because maybe my common ratio is -1/2, -1/3, -2/7. If the absolute value of all those things would be less than 1. So fractions that are less than 1 is a great way to think about it. If that's the case, when I take a fraction that's less than 1 and I raise it to a really big number, that expression is going to get closer and closer to 0. So if this is the case, and I'm looking for the sum of an infinite geometric series, so we're going to go ahead and replace s sub n with just s, because now it's not necessarily an n or an n number of terms, it's infinite, an infinite number of terms with this going on. Geometric with a ratio whose absolute value is less than 1. So if 1 minus this expression is going to turn into, which this will turn into 0, so 1 minus 0 is 1. So really I've got a sub 1 times 1 over 1 minus r. And an even simpler looking version of this would be to take, multiply it together. a1 times 1 is a1. So here's the actual formula that we're going to use to find the sum of an infinite geometric series where the common ratio has an absolute value less than 1. We take the first term divided by 1 minus that ratio. There would be our formula that we're going to use for the majority of the problems in this lesson as we practice finding the sums of infinite geometric series.